Okay, YouTube fam, I finished the rest of the soldering on this. Last time I was live, we were running the base connection resistors to the input on the variable resistor. I believe was the last step. Now, since the last video, I have soldered the output of the variable resistor to the input on the switch over here, and from the switch I sent the connection over to our positive side where all the LEDs are connected via this power rail right here, which contains all the positives of the LEDs. So again, we went from the 10K base resistors on all three transistors over to the input on the variable resistor right here, and then on the output of the variable resistor to the switch, and then from the switch over to the positive. So that took care of the positive connection, and then for the negative we had to go on all three transistors. We had to go to the emitter pin on all three transistors. From the emitter pin we came over to this negative connection right here. So here's a transistor, here's a transistor, and here's a transistor. So 1, 2, 3 transistors we sent over here to the negative, and then from the output of the variable resistor we sent over to the positive LEDs. And then at that point I just soldered this 9-volt battery connector to the positive and negative, and that completed everything. That completed the entire operation. So you can see here's this big wire that comes all the way from the output of the switch, comes over and feeds into the power right here, and that was the last connection. And then another one of the last connections was the emitter pin on each transistor. We ran over to here, and then again we soldered on the 9-volt battery connection. So that's pretty much it. I got 27 LEDs. All the positives are soldered together, and then the negatives are done vertically. 3, 3, 3, 3, 3, 3, 3, 3, 3. So there were 9 sets of 3 LEDs. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I soldered them. I soldered each transistor, got 9 LEDs, and I went in a cross pattern, so whenever the astable multivibrator is functioning, it would give a cool effect. So along with the 3 transistors, there's 3 capacitors. There are, from the LEDs to the collector pin on each transistor, there's a 470 ohm resistor, and then from the base of each transistor there's a 10K resistor that feed into the input on the variable resistor, which will control the speed at which it vibrates. And then I put a switch on here to turn it off and on, and in the off position it seems to make a cool, I'm not too sure what's going on, it's kind of like a feedback. It's doing some type of feedback setting that actually makes the LEDs fade a little bit. It's kind of cool. So we'll check it out here. I'm going to turn it on so you guys can see. I'm going to add another plate here to try to, I'm going to try to make a housing for it that will hold the battery. I'll put some longer screws in here to try to make like a little box for it, and then I'll strap the battery in here so it looks nice. I don't want the cord to be bouncing around too much for fear that the connections might break. So it's not completely done yet. Like I said, I want to make a housing for it, and then it'll be finished. So let's try it out. I'm going to plug the 9-volt battery into it and turn it around this way so I can control it. Then if you flip the switch, it's got this kind of cool effect. I'm not too sure how that's created. Maybe some type of feedback through the transistors. You can tell the capacitors are involved the way that it fades. I kind of like how that works. You can see it kind of does its own thing. Then you turn it on and it goes back to normal operation. And again, you can spin the variable resistor here to control the speed a little bit. That's all the way down. Then you flip the switch, it does some other cool things. Flip it again, and they all come on until you turn the variable resistor. So overall, I'm really happy with the fact that it is working without me having to completely go through the entire board to figure out what I did wrong. It seems like I got it right on the first try, so I'm very happy about that. Of course, as I mentioned in the previous videos, I built it on a breadboard working before I soldered it all together. That's probably the best way to do just about any electronic project is to build it on the breadboard first before you start soldering all the parts together. And again, I am going to make a base for it, so from that point it should be complete. I appreciate you guys tuning in and watching. It was a fun project. This is the second one I built. The first one was a 4x4 RGB matrix that I coupled with an Arduino microcontroller and downloaded a program into it to make it do all kinds of cool stuff. You should be able to find that video on my YouTube channel, or at least a demonstration of the one that I built. This time I didn't want to make that one that big, so I just stuck with 3x3. So yeah, it turned out pretty cool. I'll probably keep it for a little while. I don't know. I might try to sell it on eBay. We'll see. I sold that Arduino microcontroller 4x4 cube for $100 on eBay a long time ago. That's what kind of gives me the idea to put this one on too, see how much I can get for it. I'll probably keep it for a while. I like it. This is the first one I built just using transistors, so I'm pretty excited about the job. I'm pretty excited about it. So it doesn't shut off. I gotta unplug the battery. So again, thanks for tuning in and watching the construction of this one. I got fairly lucky that everything went smoothly without any major problems. Here was the schematic I utilized. Over here is the battery connection. You can see the LEDs are on the positive side of the rail, and the transistors are on the negative side. There's the variable resistor over here. Now I have constructed a second LED matrix cube. I'll show this one to you guys. This is one I built before the blue LED matrix cube. You can see it don't have any components yet. This one, these are RGB LEDs, and other than that, the only difference besides the fact that these are RGBs and not blue is that all the negatives are soldered together. So on the blue one, I have all the positives soldered together. However, on this one, all the negatives are soldered together and the positives are coming down. Well, if you look at this schematic here, this one requires all the positives to be soldered together, not the negatives. So in order for me to construct a similar multivibrator circuit like the blue one, I'm going to have to find a schematic where the transistors and the LEDs are swapped positions. Now I think I already found one, so I'm going to double check the schematic and see if it will work with this one, and if it does, then I'm going to build this one as well. And this one will be really cool because it'll change, other than blue, it'll change all the colors of the rainbow. So I'm excited to get started on this one. I just got to double check to make sure I find a proper schematic for it, because as I mentioned, all the negatives are soldered together on this, and then the positives are coming out through here on the bottom, and that won't conform with this schematic. So again, I'm gonna have to find something else. So again, I'll pop this one on for you guys one more time. It's a 3x9 matrix cube that I built using 3 transistors. You can adjust the speed with the variable resistor, and then it has this cool effect whenever you flip the switch. Then you can flip it back on. Again, I just constructed this one with 3 transistors. It's got 3 capacitors and 6 regular resistors and a variable resistor here, all running on a 9-volt battery. So thanks for watching the series on the blue one, and if I have all the parts, it looks like I'm going to have to get some more transistors, but if I can get all the parts together for this RGB one, then I might do some videos on it. Thanks again for tuning in. Enjoy the rest of your week.